I ran 1,000 GPUs in a warehouse for almost 3 years straight, and it only cost me $25,000 a month. Doing this in a typical Tier 3 data center would cost you almost 3 to 5 times as much money. By doing it ourselves, we were able to save millions of dollars. And today, I'm going to take you through all the components that go into a data center, and I'll let you know where I think we got away with it and where I think we should have spent more money. Data centers aren't unnecessarily expensive. All that engineering and redundancy that goes into them actually serves a very valid purpose. But in a lot of cases, good enough is good enough, and the money that you can save by not having some of that functionality actually outweighs the technical drawbacks of not having it. In our case, we actually took it too far, and there's a lot of things that I wish we had in our data center that we didn't, and ultimately it made it very, very difficult for us to scale and grow our business. So my story is that while I was growing the business, I took it from, GPUs in my apartment to a garage and ultimately ended up in a warehouse. But when we made that decision to build a DIY data center in a warehouse, we were weighing that against actually just renting colocation space from a proper Tier 3 facility with certifications and all of the things that we'd need to run a stable environment. And we were totally scared away by the price. And honestly, it was cost prohibitive for the operating model that we were running in. The way the colocation business model works is they actually bill you based on the amount of power provisioned. So for a GPU server that needs a full 6 kilowatt circuit, you need to pay them monthly for that whole 6 kilowatt circuit, whether you're using it 20%, 30%, it doesn't matter. Once you get into larger deals, you can do a fixed price plus energy costs. But no matter how you model this out, a colocation is going to have a really hard time giving you a price less than $150 a kilowatt per month. And I would challenge now, it's only gotten more expensive. So when we saw all of this, we decided, let's just do our own facility. And all of the models we ran, it looked like we could get it done for $50 a kilowatt per month. Or less even in a lot of cases, because if we weren't using the power, we didn't really have to pay for it. So that was the thought process there. And honestly, I think that's the right decision for this type of business, but our execution was wrong. Whether you're building a facility in a warehouse or you're renting it from a colocation, all of the components of it are going to be the same. And it's the extent that these things are implemented that are going to affect your reliability, your redundancy, and the ultimate tier of your data center. And so what you want to do is make sure that you've got the right mix of things that suit your application or your customers, so that you're paying for the things that you should be and not paying for things that you're not getting any value back for. So the first component that I want to talk about is power. Obviously, if you're going to build a data center, you need a building that has a lot of power, or you need to add a lot of power to the building. At a high level, the way that works is there's obviously power on the power lines. That's coming in at a very high voltage, and that goes into a transformer, which steps it down to a voltage that's actually usable inside your facility. You want to make sure that you're using 3-phase power in your facility, just because a lot of data center equipment is just built around 3-phase. Single phase is possible. There's PDUs and different pieces of equipment that can handle it. It's just harder to come by, and it's going to be cheaper for you if you're using 3-phase out of the gate. In a data center, there's sort of one step that is different from the power that's already going to be in a warehouse. In a warehouse, you're probably going to see switchgear or just big panels that have the power coming in off the transformer, and then it breaks it out into different circuits and different breakers that are spread out throughout the facility. So what you're going to add in a data center is you're going to have UPS systems, which are essentially just big battery systems that receive the power at really, really high voltage, really high amperage. So this could take your 480 volts coming off of your transformer. It's going to then basically put that into the batteries. And then on the output of that system, you're going to have clean conditioned power that you can feed into the PDUs that are going to be in your server racks. A PDU is essentially just a power bar, but it's designed to be either rack mounted or carefully sort of vertically fit in the back of a server rack. So that's essentially how the power is going to work. I'll talk more about UPSs specifically, because that is just like the real difference between getting a warehouse that has a whole bunch of plugs on the wall and having an actual stable facility. The next most important component after power is going to be the internet. So you need to make sure that to the building that you've selected, you're going to be able to get dedicated internet plans that allow you to run your own BGP router. And you need to be able to do this at the bandwidth that you see fit. So for us, we had a 10 gigabit per second link coming into the building that was backed up by a 1 gigabit per second link. And those both need to be dedicated internet plans because we're going to run our own router, which allows us to send traffic down whichever link we see fit. This is different from, a typical internet setup where you're just going to have a single path that relies on your ISP's router. And if this, the path to that ISP's router gets severed, obviously your internet goes down. And you can't have that in a data center because if, there's a small outage, all of your customers are going to be able to pick that up and wonder what happened. So, step one is find a provider that can offer BGP and dedicated internet. The second is going to be, make sure that you can get the bandwidth that you think you're going to need. And like I said, for us, we were able to do about 100 servers on a 10 gig link. With the BGP, and this is, I guess, the last thing I'll call out here, you're going to be able to get your own public IPs assigned to you from the organization that controls that. And the way that we operated our network in the data center was initially we'd have the IPs come into the system, to our router, and we'd assign private IPs to the machines, and then we'd use something called network address translation to basically map those public IPs to those private IPs. And then that let me basically, just tell the customer, oh, hey, your machine has this IP, you can log in over the internet. And then we switched the model, and we actually just started assigning the public IPs directly to the links on the systems. So we deploy a server, install its operating system, and then right on the interface in the operating system, we're able to just give it a public IP directly. And that made, deploying, redeploying servers really, really easy, where I could tell a customer, hey, this is your IP address. And then once they were done with the server, I could wipe it, put a new IP address on it, and give it to a different customer. To achieve redundancy in these systems, you're going to use more units than you actually need. So you'll see a way of notating this as N+1 or N+2. And that essentially just refers to how many extra redundancy components are we adding in the event that we need to do maintenance on one or something fails. And you see that notation come from the storage world, where you're talking about how many disks can we lose before we lose data. And in the air conditioning world, it's also true. So let's say you do all your math and you only need one air conditioning unit, based on the size of the unit and the amount of power you have. You are still going to need to get 2 units, because if for whatever reason that one unit fails, you can't operate with no air conditioning. Maybe you can, but then obviously you're putting your SLAs at risk. So in the air conditioning systems, my recommendation would be to get many smaller systems. That you can find the math online of, how many tons of air conditioning do I need for how many kilowatts of power going through computer systems. But you want to size it in a way that you've got very granular control. And, maybe you've got 20 different air conditioners servicing all of your, different little areas. But in every area, there's multiple, air handlers and condensers all servicing that same spot, so that if any component were to fail, it's fine because there's still lots of air conditioning going in. So that's how the redundancy works. And the final sort of component to cooling is the humidity. So if you're running a lot of air conditioners, you're going to be pulling a ton of moisture out of the air. And in a data center, you don't want super low humidity, and you obviously don't want super high humidity. So there is kind of a sweet spot that needs to be maintained. And if you're not going to buy a typical, data center air conditioning unit, there's going to be no controls built in, and you're going to have to do this, with your own controls. And this could be as simple as buying humidifiers that turn on when humidity gets too low, and dehumidifiers that turn on when humidity gets too high. But if you fire all this up and then you see humidity's at 5%, you're at risk of creating a big static shock somewhere that could destroy a ton of hardware. So that's how you want to look at the redundancy around your cooling systems. Free cooling is another way that if you're building your own facility, you can reduce a ton of cost. So air conditioning is going to use, 30 to 40% of the power in your data center. That's just like a typical estimate. So let's say you have 100 kilowatts of computer systems running. You're probably going to want, 30 to 40 kilowatts of air conditioning running to actually cool all that down. You can get away with using outdoor air, just sucking air in from outside and running that colder air through your systems and just ejecting the hot air out of the building. But there's a lot of things that you have to do to it to ensure that it's, suitable to go into the systems. And that comes back to obviously the temperature of that air, the humidity of that air, and then you're going to want a lot of filtering on that air. So you'll see some, computer hardware that comes out of these old crypto mining facilities that are doing this. And it's just absolutely destroyed after 3 years because they're sucking wet, dirty air onto it and it's causing corrosion. There's like salt buildup on it. And all of those things just reduce the usable life of your equipment and ultimately the resale value. So you're, paying sort of an accelerated depreciation schedule that might be, faster than the money you're saving by just paying for air conditioning. So that's the final component there. There is a design. I'll try to find a photo of it here that I saw of like a proper cloud company doing this, and they built specialized structures that are like quasi data centers where they have a slanted roof that they essentially just allow all of the hot air to go up to the ceiling, which is I think it was like 30, 40 feet up. And because the roof is slanted, they just had like an opening along the top of the slant that basically sort of directed all of the hot air out of the building. And then all of their air intakes were down at the bottom of the building, which would allow basically the floor to just be outside temperature. And then you've got that conditioned air coming in from outside, and then that, hot stale air coming out the top. So if you're doing this in your own building, I think you actually have a lot of sort of engineering freedom over how you want to direct that air for your free cooling. Next up, we've got generators. So with the UPS systems, you're going to have that 5 to 15 minute buffer of battery power that you can rely on in the case that your primary power goes out. And assuming you're not getting an entire secondary circuit hooked up to your facility, you're not going to have another power source to fail over to if the outage is longer than 5 to 15 minutes. The way that you get around this, and I'm sure everyone's seen this before, are with large gas generators. And these are typically like big diesel generators that can output, hundreds of kilowatts, megawatts of power even, to power a facility in the event that its primary power goes down. Data centers have, huge reserves underground of fuel for the doomsday scenario where if power goes out, they can run for months at a time and just get, deliveries of fuel brought to them. So backup generators, I think, are incredibly useful. And if you're planning on, doing this at scale, I highly recommend UPS. And the next logical purchase would likely be to add in generators if you want to have the ability to offer your customers an uptime guarantee. The last thing you want to do is have a bunch of customers asking you when power is going to come back on, and for you to have the only answer that is, when the utility company turns it back on. Because anyone who's using a cloud service from you, they're likely expecting that you're in a data center already, and they're likely expecting that you have some form of backup power. So generators, I think, are, that next level where you take your, you go from calling yourself a warehouse to, a proper data center. I kind of touched on it already. Secondary power is literally just another utility coming into the building. And data centers do this where they get, one utility coming from one substation, and that's sort of the primary power. And then they get another utility of the same size coming from another power substation, so that if an entire part of the grid goes down, like an entire substation goes offline, they have another power source coming from somewhere else. And this would act as like an intermediary failover before generators kick on. And I think this only really works at large scale. I never did this at our warehouse. I actually didn't even know where to start. There was like one utility company in the area. So The idea of getting a second substation was just like not possible. But if you're renting from a proper colocation, they're doing something like this. Finally, we have fire suppression. And it's funny putting it last because it seems like, obviously it's very important to be fire safe. But the reality is that if you're doing a data center in a warehouse, you have very low, I guess the way to put it is the containment and the airtightness of your facility is going to be really, really low. And what that means is that a lot of the data center fire suppression solutions that use sort of like inert gas or CO2 flooding or all of these different things that require an airtight room to actually be effective, you can't really use. So, and they're very expensive. So you're likely going to end up with water sprinklers and a whole bunch of fire extinguishers. You can get fire extinguishers that are, not going to damage your computer hardware, but you're still going to need something in there to actually get occupancy on your building. And water sprinklers are allowed, which sounds crazy, but the logic is that if fire is reaching those sprinkler heads to set them off, any damage that water would cause on your systems is already being done by that fire. So it's more about the safety of the building and the people in it than it is about saving your systems at that point. So that's all I've got for you. I hope this helps at least one person, plan or build a DIY facility. And I'd love to hear from anybody that has any stories around this, because we had a lot of fun building ours, and it set our business back a lot, but it also saved us a ton of money along the way. So it's hard to say that if, we'd spent even more money on all this stuff, like, would we really be in a better place? It's hard to say.